morning, everyone. My name is Giovanni. I am a computer science major here at California Lutheran University. This summer, I was investigating how to use natural language processing to communicate ideas more clearly in writing, and I was under the mentorship of Dr. Craig Reinhardt. So, a little bit of background. So, what is NLP? Take a look at that. So, NLP is an acronym that stands for Natural Language Processing, which studies the interaction between human language and computers, or rather how computers are able to understand a human language and interpret it and find meaning based on that, using methods from text analysis, whether it be related to machine learning or not. And what's it used for? Well, whenever you go and start typing into Microsoft Word or Google Docs, you start to see that you have spell check coming in and telling you, hey, this is misspelled. Why did you misspell this word? Or, hey, why is this word duplicated? Why do you have the to twice? So that's one of the applications, and I think a more relevant one is, whenever you're typing into a text message and you're going to send it to a friend, and it automatically predicts whether you're going to say turn right, and like if you write the word turn, why does it predict the word right? So that's all under our kind of natural language processing. And basically what this does is it takes lots of samples of data that have been known and collected over the years or that have been sampled to it, so that an algorithm, which is just a processor of steps that a computer can take to complete a task, and it analyzes, okay, turn, so I want to predict that it might be right, left, forwards, backwards, etc. So this is something that intrigued me and I wanted to take a look at a little bit more further. And I also was looking at spell check and different things in Microsoft Word. I realized there was a problem. So there's various limitations that come with things like spell check and Microsoft Word. And it only really checks for misspellings and contiguous duplicates. It doesn't look at grammar, and its little sense of grammar that it has is very limited. It doesn't really proportion anything that might be, how do I say it? It might be it's not coherent, and doesn't really track redundant content. It makes you just continuously edit what you've already done, and it doesn't really give you more time to produce more content that you could be producing. And that's a problem. That hinders productivity, and that does not allow for you to continuously keep on writing. So I came up with some questions, and as I was looking at these different problems, I started to see how can the time spent eliminating redundancy and going back and editing through your text, how can it be minimized? And redundancy is interesting because you can have the same sentiment between two sentences or two contiguous pieces of text, and they can be completely different. And how can we allow not humans to continuously go back and do this, but how can we just let an algorithm or a computer do this for you? How can this be incorporated to your usual text processors that you use every single day? And most importantly, how can we optimize this to remove any words that just don't make sense or are just the same thing repeated twice? And how can this be extended to different languages or just to different applications? So to go get some relevant work, and so we had one article that stated from 2007 that used part of speech engrams to check whether a sentence is grammatical or not. So checking is this grammar, is it ill-formed, meaning whether it makes sense or whether it's not necessarily the most sensible sentence that you can make. And an engram is just a sequence of items in a piece of text. So if you have, for example, the common phrase, the quick brown fox jumps over the blank, that would be a 7-gram because it's composed of 7 words. So engram basically allows for there to be predictions to what comes next. And I found that to be interesting, and how could this be applied to an idea that I was coming up with. So then I looked at Senatorp and Alia from 2012 that created an annotation tool called BRAT that annotates text by different parts of speech and using named entity recognition, which is the classification of text, otherwise known as named entities, into different categories, whether it be like the president, an organization, person, etc. So how could this be combined to make something even better from these prior ideas? How can this be extended from the work that has already been done in the past few years? So I decided to collect some data to allow for this to happen. So the first step was to collect sample text from a site called Project Gutenberg that has different text from different books, whether or essays or just famous speeches such as Gettysburg Address. And although that's the end goal, to be able to see what redundancy occurs in those texts, it's not the ideal sample size because a lot of those samples were just very large relative to what could be used to originally test how to eliminate redundancy. And so took a look at smaller samples that contained said redundancy. So I made sure I made small amounts of data that were around 3 sentences of length to allow for this to go faster and not to continuously repeat myself. Whereas in any essay that came from Project Gutenberg, that could be too large to see if the algorithm works or not. So the technical tools that were used for this were the natural language toolkit, which allows for natural language processing to be used and without having to recreate everything myself, and Gensim, which is an open source library that incorporates different algorithms and models to be allowed this to happen. So with this, an algorithm was devised called the fluff cutter algorithm, and this is more of an outline of what goes on. This is not the full details. Up in the graph is just the occurrences of a sample text of speech that I actually gave. So it highlights 2 words, specifically the word redundancy and the word text, which were used more frequently than the ones and the rest of the words that were just used once. So how did this occur? So first, the text was tokenized between word and sentence to allow for not only word comparisons but also sentence comparisons. And all the stop words were filtered out. So stop words are all the words like and, of, the, etc. that don't really allow for any actual content to be expressed. And afterwards, sentences that had the same sentiment. So if you have a sentence of like, I like to eat pizza, and I don't like to eat pizza, that's a positive and a negative. Those wouldn't be compared, and those wouldn't be considered redundant because it's obviously 2 different sentiments, even though they have similar words. And afterwards, word occurrences were counted. So how often they occur between 2 contiguous sentences, and then took a look at frequency distribution to see which words weren't repeated between that radius. So right here, this is the actual algorithm at work based on a text editor that was created to show it. And what's highlighted is basically what the algorithm suggests they should eliminate. So as you can see, it was from the graph that said both redundancy and text were the most repeated words within that radius, and those are the ones that are highlighted. However, there are some faults with there because I says it was repeated even though I doesn't necessarily make it a word that communicates content, and some other punctuation was repeated. So there's still some work to be done. So going off of that, this is a faulty algorithm because words must occur more than once, and when this happens, it doesn't mean that they should be highlighted. It does not necessarily mean that it is redundant, even with the sentiment check. So this comes to the conclusion that language is ambiguous. This is the biggest thing that natural language processing always tries to tackle with it. The ambiguity of language can show that sentences may still be redundant, even if words do not have anything in common. And it's hard to add any elimination functionality that doesn't create suggestions, because this can easily say, hey, these 2 sentences are redundant, but how can this be improved? Why does language in itself have to be so ambiguous when it comes to speeches, books, you name it? And that's the biggest problem right now that arises with this algorithm that has been created throughout these past few weeks. So let's take a look at the next steps. So the first thing is to actually fix this algorithm. You have to build more tests to filter this out. So throughout this test, machine learning, which is how using statistical models to be able to allow computers to do things without being explicitly programmed, that was not used throughout this current project. So the first step is to incorporate more machine learning models to be able to process the text more efficiently, and how to optimize this. Because in order to get those highlights going, there have to be various passes to keep on going, and that takes time, and that does not allow the user to have that nice experience of easily checking for redundancy. It constantly has to go and store these words in computer structures, and that takes a lot of computer memory, which is very bad, in other words. And how do we store more words from larger samples? The sample that was there was very tiny. How can we expand this to cover both and things like that. And that is pretty much where I got to so far. Thank you very much, and I would like to open it up to any questions and concerns that you may have. I appreciate your time. Yes.
So as soon as you said Google Docs and redundancy, since you're working, usually Google Docs, it's supposed to be so you can work with collaborators. Do you see applications of this algorithm to kind of find redundancies when multiple people are, like different styles? Kind of, I guess, say we're writing this paper together.
Yes.
Bring it back together, but finding the redundancies in what we've already written.
Yes, that is actually one of the main goals. That's one of the extensions that's going to be coming with the next steps, is to be able to incorporate everyone working collaboratively, like, hey, I already wrote this. Let's eliminate this from here. You click on it, highlight it, this is highlighted, this is bad, let's take it out. This has already been written. So it's actually one of the more applicable points of this because you have multiple minds working together to be able to incorporate these pieces of text in there. So we want to be able to take that out. And that allows for all the filtering to come in, and that's where the clear algorithm comes in. Yes?
So does the application actually get rid of it, or it just highlights it? And then you
Right now, it just highlights it because if it were just to be able to get rid of it, even if there was an undo button, it still makes no sense when you just take away those words because you still have to fill stuff in there. You would have to eliminate either A, the entire sentence. So right now, we're leaving it up to the user to just suggest. The point is the user doesn't have to do any thinking. It just, oh, is this highlighted? Let's just take this out. Or, oh, let's leave it in. It's more of a suggestion based. Yeah.
Rather than, I guess, computing how many times a word is repeated in a sentence, would there be a way of like you said, doing the learning of the computer where it says, here's one sentence that I've said, and then later on in my paper or essay, I say the sentence completely different with none of the same words, but it has the same content. So is that through the computer learning over time that this is one sentence and this is the content that I have, and then later being able to decipher that that sentence has the same content or meaning?
Yeah, that's where the machine learning comes into, because right now it specifically meant if you get the same word repeated across 5 sentences, it makes no sense because it can be in completely different content. That's why the phrase contiguous comes up a lot, because that analyzes whether it might be referring to the same specific content because they're just put together. That's where the word redundancy was highlighted, because it was used in 2 sentences that came one after the other. It's like you don't need to say that, we already know you're talking about redundancy. Does that kind of make sense? Yeah. Ariel?
Related, yeah, I was going to ask your algorithm, is it proprietary in a black box, or do you have the ability to manipulate variables within the algorithm?
Yeah, it's mostly, as of right now, it's more built in because it was just coming in from starting off, playing it out. How is this going to work? How is this? I'm going to try to be as efficient as it can with the time allotted. So for right now, it's mostly just built in, but we do want to extend this to get to a point where it just uses more machine learning models, becomes more formal, and becomes, as I said, more proprietary. And that's why I didn't really show anything that had to deal with the algorithm, because it kind of is by intellectual property. So I just sort of stated the outline to give you an idea of what's going on.
So you have the ability to manipulate the algorithm, add components, for example, neural network-based approach.
Yeah.
Based on the learning principle.
Mhm.
Do you have that?
Yes?
The coherence of speaking is reflected in writing, and coherence of writing is reflected in speaking.
Okay.
Now, if we have a machine telling us what we're doing wrong in writing, that will create a certain sense of reliability, meaning I will go ahead on writing the paper expecting machine to point out my wrongs and not myself looking for them.
Yeah.
So, is there any risk of its detriment being greater than its benefit?
Yes, because that's actually one of the current, that's why I mentioned that it was a faulty algorithm, because in many ways you could be taking away that kind of organic way that you're kind of relying on the machine to do this for you without you actually going in and checking for it yourself to see if it makes sense. You do kind of build a reliability, and that is a possible detriment that could come into this. However, this is why machine learning models are planning in the stage to be able to be incorporated to this in order to make the detriment less and make the benefit more. Because as of right now, yes, it is more of a detriment to go right now. It's more of a sample to see what it can do rather than this is like the final, this is it. So it is the extension right now, I can definitely see where you're coming from, and I thank you for mentioning that because there are many detriments, but thankfully it has already been taken into account.